Hey, welcome back, students. In this video, I want to take some time to talk about the phase type designations that we see in chemical reactions. There's only a couple of them, and I've already got a generic reaction here in front of us. And so the main thing that we want to know here is things about the phase types. And so let's go ahead and put that. In fact, let me move this over just a little bit over here to the right. And what I'll do here with the phase types is kind of write them down here for us at the bottom. So the phase types can be of some type here. It's either going to be a solid, it's going to be a gas, it will be a liquid, or one of the other items that we saw that I mentioned in a previous video here is that it is aqueous. Okay, and so how do we represent these inside the reaction? And so let's go through these one by one. And so whenever we're dealing with a solid, the solid is going to be represented as a subscript S, and we usually put it inside parentheses. Okay, so I'm going to put here lowercase s. And then for the gas, that one there is a lowercase g, also in parentheses. Liquids are represented as a lowercase l, in parentheses, and the aqueous is represented as a lowercase aq inside parentheses. Now, all of these are going to be written down as if it were a subscript. So, for example, in this particular generic reaction that we've got over here on the right-hand side, let's say that AB here, let's pretend that AB was a solid here. And so in which case we would designate this compound with a subscript parentheses lowercase s to designate that it's a solid. If we pretend also that CD here is a liquid, then we would write here lowercase l. Okay, and then over here at the very end, let's pretend that both of these compounds at the very end that are generated, let's say that one of them is going to be another solid, and let's make the other one aqueous. And then we would designate here the solid AD product. We would say that would be a lowercase s, but then the aqueous CB product would be AQ designation. Okay, and the reason we want to know this is because when we look at this reaction, the information that's provided to us is very informative. So we know that we're dealing with some solid. This could be a crystalline, or it could be some kind of solid material that's beyond crystalline structure. And when we got it in solution, or when we place it in solution, this compound CD, then we do know because of the products that we're going to get some kind of displacement. We see that here with the AD. We're going to get another precipitate showing, but we also know that we're going to get some kind of ion. So whenever you see an AQ designation here, yes, the AQ means that you've got that particular compound dissolved in water, but it also means here that you're going to see the formation of ions formed. Okay? Because that's one of the takeaways from an aqueous solution. So these are the 4 phases that you need to know for this particular section. It's not very complicated. You do need to know that you also need to identify these phases every time from this point forward. You do need to identify all of the phases for all of the compounds, reactant species in a chemical reaction. And we're going to continue to make our journey here as we start and build the argument here for how solubility works. So I'm going to be talking to you about the role of water in solubility because water is the most prevalent solvent that we are familiar with. It's not the only one, but it is the most common one that we use at this level. And so we'll use our understanding of water, its molecular geometry, and try to build that understanding as we build the foundation for this discussion that we're building up to here called the net ionic equations. So if you haven't already done so, go ahead and subscribe, keep watching, keep learning, and we'll see you in the next video.